All right, so this is factoring the greatest common factor. So our big goal here, obviously, is to be able to find the greatest common factor. But just note that finding the GCF, so finding the GCF is the opposite. So the opposite of distribution. All right, so you know what distribution is. All right, so this is going to be the opposite of distribution. So real quick, let's just do a quick recall. Right, when it comes to distribution, I'm going to see this first, and then we're going to talk about undoing it. So if we had, let's just say, 4x times x minus 7. All right, so distribution, this is multiplication. In and of itself, we're going to multiply, right? So 4x times x. So I'm going to distribute the 4x to the x and the negative 7. So 4x times x is 4x squared. And 4x times the negative 7 is going to be negative 28x. All right, so we multiplied 4x times x, and we got 4x squared. We multiplied 4x times a negative 7, got negative 28x. All right, so that is distribution. Now, when it comes to the greatest common factor, so GCF, I note it has to be the biggest factor that these things have in common. So, one thing I'm going to do is I'm going to break this into two parts. First of all, we're going to deal with the numbers, and then we're going to deal with the variables. And I want to make sure we recognize what's happening with this problem here and going backwards. But we're going to be able to see, I'm going to use this as an example of when we do more of these going forward. So now, when it comes to the numbers, I need to determine, so the largest common multiple. So largest multiple that each one of those things have in common. Excuse me, I take that back. So the largest factor as far as the numbers go. When it comes to the variables, I'm looking for the least degree or least exponent. So the small, here, let me use this. I'm going to look for the smallest exponent. And that's going to make a little bit more sense a little bit later on as we go and do this. So if we were to look at 4 and 28, just looking at 4 and 28, if I were to break down, so let's do this, 4x squared minus 28x. So the goal for this example is to factor. All right, so I want to factor 4x squared minus 28x. Well, I know 4 breaks into 2 and 2. That might be some help. But 28 breaks into 2 and 14, 2 and 7, and that's as far as I could take it, right? So what all do they have in common? Well, they have a pair of 2's, right? And 2 times 2 we know to be 4. So between the 4 and the 28, I know that they have a 4 in common. This is not the same as simplifying radicals, but this is what I'm trying to find is what all do they have in common. So in fact, I'm going to do it like this. I'm going to circle these individually. That way we don't get it confused. So a 2 comes out, right? They have a 2 in common, then they have another 2 in common, and we know that 2 times 2 is 4. All right, so I know that at least a 4 is going to come out, right? And now I'm going to look at the variable parts. The variable parts, I'm looking for the smallest exponent. Well, here I have the exponent of 2, and over here I have an exponent of x to the first, right? So I'm going to take x to the first out. So I know that I'm going to have an x to the 4x come out. So now how do I determine what's going to be left over? So after I determine what number was coming out and what variable is coming out, then I'm going to determine what's going to be left over on the inside. Well, distribution was multiplication, so greatest common factor. So factoring out, I have to divide. So over here again on my scratch work, I'm going to take 4x squared and divide that by 4x. Right, so 4 divided by 4 is gone. X squared divided by x is just simply x. So I know that I'm going to be left with an x here. Negative 28x divided by 4x. Well, negative 28 divided by 4 is a negative 7, and x divided by x is 1, so that's gone. So I know that I'm left with a negative 7. So now I can see 4x times x minus 7. Is that the original? Well, yeah, sure it is, because that's what we had to begin with back over there. So then if we want to break this down into steps, when it comes to the GCF, if I were going to break this down into steps, so the GCF steps, I'm going to determine the largest factor numerically. I'm going to find the variable that's going to be taken out, so the variable that comes out. So I determine the largest factor that comes out, find the variable that comes out, and then I divide term by term. So if I were going to break this into steps, I would say the largest factor, so the number, was 4. Find the variable that came out, so that would have been the x, and then divide term by term. Some things to look out for, so things to pay attention to as you're going through and dealing with the greatest common factor, is that you do not take 1 out. Right, so if it was 11 and 7, if it's 11x squared minus 7x, well, 11 and 7, they don't have anything in common other than a 1. Right, so if both of these numbers at the beginning stage are prime, then we don't deal with that. That's a little too, I don't want to say silly, but it's redundant if you pull a 1 out, because 1 times anything is itself, right? All right, let's do a couple of examples here to hopefully get this solidified. Let's see. Let's take a look at 12x squared plus 6x. And let's try this one here. So 12x squared plus 6x. Well, between 12 and 6, I mean, we already know, like if I broke 12 down, it'd be 2 and 6, 2 and 3, right? Broke a 6 down, I get a 2 and a 3. So I know 2 and 3 are common, so we know that 2 times 3 is 6. So I know at least a 6 is going to come out. And between x squared and x to the second, x to the first, I know at least an x is going to come out of there. Right? The smallest exponent, I want to bring that out. So then I look off to the side. 12x squared divided by 6x. Well, 12 divided by 6 is 2. X squared divided by x is x. So then I'm left with a 2x. Now 6x divided by 6x is 1. So I get a positive 1. So then I'd be done. Right? So there's nothing more I need to do with this. And I'm done. Now look, doesn't this look like you're about to distribute? Then that means you're doing it right. All right, let's take a look at another example here. What if we had, let's do 3x to the 5th y plus 18x to the 3rd y squared plus, let's go with a 9x to the 4th, y to the 3rd. Okay. So now I have a bunch of numbers and a bunch of variables, and that's okay. Well, between a 3, 18, and a 9, I'm not going to break this down. I already know 3, 18, and 9, already they all have a 3 in common. And now I'm looking for the smallest exponent. X to the 5th, x to the 3rd, x to the 4th. So the smallest one between a 5, 3, and a 4 is a 3. So I'm going to bring out x to the 3rd. And now I have a y squared, y to the 3rd. The smallest one between the y's is a y to the 1st power. So I'm going to bring that guy out. And now again, over here on my scratch paper, this is where I'm going to do my division. On this side, I got to do some division. So I take each term and divide it by what my greatest common factor is. So 3x to the 5th y divided by 3x to the 3rd y. The 3's are gone. X to the 5th divided by x to the 3rd is x squared. Y divided by y is 1, and it's done. So I'm left with an x squared. Now I go 18x to the 3rd y squared divided by 3x to the 3rd y. 18 divided by 3 is 6. X to the 3rd divided by x to the 3rd, that's 1 and it's gone. Y squared divided by y is y. So I have a plus is 6y. And then finally my last term, we have 9x to the 4th y to the 3rd divided by 3x to the 3rd y. 9 divided by 3 is 3. X to the 4th divided by x to the 3rd is x. Y to the 3rd divided by y is y squared. So then I'd be left with a plus 3xy squared. And that's as far as I could take it.